Okay, so you've probably been watching a movie or listening to a TV show or whatever it may be, and you've heard these impacts or these punches or these explosions or gunshots that just sound like they've got that snap to them, like this impact, this transient information that just feels like it punches you in the chest, and you wonder, like, how do I achieve that? Well, I actually made another video about how to achieve cinematic impacts, and I went over a bunch of different techniques to help get you there. But in this video, I'm going to be focusing on a single class of signal processors called Transient Designers. What's up, everybody? My name is Matt Yoakum, and welcome to My Sound. So, like I said, if you haven't seen the other video that I made on making cinematic impacts, go ahead and watch that. It's really helpful. It goes over a bunch of different ways in which you can take a small recording and make it into something larger. But that was more of a general overview, and in this video, I'm going to be focusing in on a single set of tools known as Transient Designers. Now, what makes Transient Designers a unique thing to use in sound design context is that they are basically there to help shape the envelope of your signal. The envelope of your signal, you can basically just think of the shape of your waveform or the shape of the sound. Now, most transient designers break this up into two main pieces, and that is your attack and your sustain. So the attack, or the transient, is that short spike that you get in the beginning of a signal. It's when you hit, the most classic example is a gunshot. When you pull the trigger, you get that loud smack. It's that sharp peak in your waveform. And then everything after that very short burst, the whole tail, ring out, or body of the sound is what's known as the sustain. So as you'll see in some of the examples that I get into, transient designers basically just give you the option of manipulating either your transient or your attack or your body or your sustain. So in this video, I'm going to be covering 3 different plugins that do transient designing, as well as a hardware version of one of the most famous one of these. And if you stick around until the end of this video, I'm actually going to be showing you a mixing technique on how to use transient designers in your mix to help your Foley blend into your production better. So without further ado, let's get to it. Okay, so here we are in Pro Tools. I've got 6 examples here, and I've got them stacked in 4. And so each track is going to have a different transient designer, and I'll just show you those real quick. So the first one, this is probably the most famous and most recognizable one. This is the SPL Transient Designer Plus. This particular emulation is from Plugin Alliance. There's another one from UAD. They're functionally the same. And so it's a fairly simple interface. There's attack, which obviously affects the transient portion of our envelope. There's the sustain, which controls the tail and the body. Then we have a link for stereo operation. There's a limiter built in so that we're not clipping, and you'll see the gain reduction meter here if you exceed 0. Then it's nice that we've got a wet dry knob here. And to be perfectly honest, I almost always just leave this at 100%. And then there's a sidechain filter, which you can turn on or off. And what's nice is that you have this sidechain solo button, which will show you sort of the frequencies that fall within it. And whichever frequencies fall within the sidechain, it will not process, which is nice. So if something's already snappy, but you want it to focus mostly on low end, you can filter out the high end or vice versa. And so I usually leave this off. I pretty much only come here to use the attack and sustain knobs, but it's nice that we have the options here. And then of course there's a gain output level. Next up is Spiff from Oak Sound. This is probably one of my favorite tools to use for transient designing these days. What's really unique about it is that you can use it spectrally, meaning I can increase or decrease, similar to the sidechain on the SPL Transient Designer, how much is getting affected in the signal path. So if I want something to be thumpy transient, I can raise the lower, or if I want the high end to not get affected, I can lower it. And it's in this boost mode. It also has a cut mode. And so this is essentially if I want to lessen the transients on something, you can increase the depth and get less transient information, or you can boost and get more transient information. There's a few other controls down here which are great. There's a sensitivity knob, which is basically how sensitive it is to transients. So if you have sort of quiet, ticky stuff in the tail, it can or cannot pick those up depending on how sensitive you've got it. Decay is basically how long the sustain sticks around. The sharpness is how fast the transient kicks in. And then the decay difference between low and high frequencies, you can adjust to that. But I'm set at default parameters for now. And I'm just going to be testing it mostly flat, at least in the beginning. And then maybe I'll probably show some of the spectral work, honestly, because that's what it's great for. And then next up, we have the Kilohearts transient shaper. So this one I'm showing because it's free. As you may have seen from other videos, I'm a big fan of the Kilohearts stuff. And what's nice is you can actually pick this one up for free if you download their plugin pack. This comes with it. So it's a great option if you're looking for something. And then last but not least, I have the hardware version of the SPL Transient Designer right here. So this is the actual hardware unit that the software emulation is based off of, and it'll be really interesting to do an A/B comparison with that. So without further ado, I'm gonna stop talking so much and let's just hear the examples of what this sounds like. And we'll just go clip by clip, but we'll basically do a clip and then I'll show before and after with each plugin so we can do direct comparisons and we'll see what we get. So here, this is dry. I'm going to add some attack. That's all the way. Back to normal. If I take away. Pretty interesting. Now, if I bring up the sustain, you'll hear the body of it come up. So everything post this initial transient, if I zoom down here, this is essentially the transient right here that it's boosting. And then everything after it is going to be the body or the sustain that it's affecting. So I can conversely add the attack and then take away the sustain and we get a super sharp sound. Okay, next is Spiff. So I can start at 0 and then default is this 3.6 and then I can go increasing it. I mean, that sounds, even all the way up, that sounds pretty good. Now, what's nice is you can affect the spectral bands and get more or less. So if I wanted to decrease the transient increase in the top end, but make it really thumpy, I could do that. That just sounds really great. This thing works awesome. I'm a huge fan of Spiff and as well as Soothe, which Oak Sound also makes. So next is the Kilohearts Transient Designer. Attack. It also has the sustain knob here. And then what's unique about this transient shaper from Kilohearts is it has this pump parameter here. And what this basically does is when you increase it, it will actually create a dip after the transient before getting into the meat of the body. So it's sort of like an in-between. It'll actually create sort of a hole. So if I bring up the sustain and the attack, you can see it's more pronounced this way versus if I go back to 0. If I bring it up, it creates a hole just after the transient and then the body follows. So we'll see what these settings sound like in their extreme states. So you can hear when I turn this pump up, it's getting rid of sort of the meat of the body there. So if we were to look at this waveform really close up, essentially what's happening is if I were to do this with clip gain, is it's getting rid of this sort of like base information here before the body happens. And it's an interesting effect. In this particular example, it doesn't work great, but on some things, it's pretty interesting for creating separation between your transient and your body. And now we've got our hardware unit. So The way that this SPL hardware unit is laid out is I actually get 4 channels. I have just the attack and sustain knobs here. And so in this way, it's actually even more simple than the plugin. So I have attack, and then I have sustain, and I have these channels 1 and 2 linked to operate in stereo mode. So when I twist the left knob here, it's affecting the right side, or channel 2, the same. Now there's also a channel 3 and 4. And so what you have with this unit is the option to run these channels either separately, where I can run stereo into 1 and 2 and then out back into the patch bay, and then separately into 3 and 4 and out into the patch bay. What I've chosen to do here for my particular setup is I'm actually running from 1 and 2 into 3 and 4. So I'm essentially doubling my capability to increase or decrease the attack or sustain after I've run through the first set. So a lot of times what I'll do with transient shapers, especially in the software realm, is I will boost something with the transient designer, like boost the attack, but then I'll boost it again a second time, and it just gives even more snap, even more transient. So it's nice that I've got the ability here to sort of chain these together in a row sequentially so that I can do that if I so desire. So here goes. Here's the hardware unit at base level. Everything is set to Unity. That's all the way up. And here's the sustain. Here's attack all the way up, sustain all the way down. Now I'm curious to match that on the software. So here's sustain all the way down, attack all the way up. Here's the software and the hardware. They sound pretty much identical, I think. Now let's try just attack all the way up and sustain at Unity. So I'm going to start with the hardware unit this time. Now the software. Maybe the slightest amount more low-end information in the SPL, but those are extremely close. And if I'm being super honest, even at flat levels, I think I far prefer Spiff. The SPL Transient Designer definitely emphasizes the high end of the transients here. So let's move on to the next example. Okay, next example, we're back at Unity. So this attack, even all the way up, isn't doing much. So this is where I would process it a second time with the attack all the way up as well. So I bypass the second one. Sustain up on the second one. All right, let's see what Spiff does. So it definitely gives way more emphasis to the low end in Spiff, even if it's at flat values. So I actually have to decrease the low band to get it to sound more like the SPL unit. But honestly, I like it with it in. And then if I decrease this, but like focus on one of the bands. Pretty interesting. Sounds great flat, honestly. Here's the Kilohearts. Let's start with these values at Unity. So with the Kilohearts Transient Designer, I can use just a single unit and put the attack up, and it's giving me the same amount of transient as 2 of the SPL Transient Designers. right? Which is interesting. And I think we'll see if it sounds exactly the same on the hardware unit. So I'm going to take the first attack here for the first 2 channels and turn it all the way up and down. And here's the second one in compared to the software, hardware. I definitely get a little bit more snap, a little bit more body from the hardware than the software this time. It's also, I think, because the transient design here is doing limiting, even with that off. It's definitely a more pronounced signal with the hardware, but I still think Spiff might be the winner on that one. Okay, so let's start with just one transient designer here. So this is a sort of a kick, sort of sweetener that I like to use for punches, impacts, gunshots, that sort of thing. It's a great low-end sweetener, so I'm going to see if I can give it some more snap. It's got a sort of a digital point there at the beginning, which is nice. It cuts through. How about more sustain? There's not a whole lot of sustain for it to grab onto, to be honest. Okay, here's it with Spiff. This is a case where I actually prefer the transient designer because I actually like the sort of like snappy point it's giving it. Spiff is saying more rounded like I expect based on the other stuff, but maybe I can emphasize the high. It's a different tone. Let me go even higher with this. That's more like it. SPL, here's Spiff. Alright, here's the transient designer. Attack. Let's start at Unity. Attack up. Sustain down. Pump up. So on this one, it definitely does give more body when I turn up the sustain. Now let's check out the hardware unit. Set these back to Unity. All the way up. A little bit of sustain. How about more sustain? Not changing much. Down on the sustain. How about another full up on the 3rd channel? Funny, the software is actually a lot cleaner than the hardware on this one. That Spiff is nice. That little ticky top end may sound like a mistake, but when you tap that onto like a gunshot or a punch, it actually sticks out in a way that it makes it feel snappy. I think the hardware might be my least favorite on this one. So very interesting. All right, now I decided instead of just a really short impact to go for something like a machine gun. Now this would be interesting to see how all of these respond. So I'm going to start back at Unity. Now I'm going to turn up the attack over the course of it. You can really hear those snaps coming up. Here it is back at Unity. And full. Sustain down. Pretty interesting. All right, now here is Spiff. Let's set it back to flat. Here it is with no processing. Now, because this is reacting spectrally, it's actually kind of inconsistent. It's doing this kind of top end and then a little bit more mid-range and then top end again as it moves through detecting different parts of the signal. Let's try the transient designer. So here it is at Unity. That one's probably the most consistent. So this pump in this case is actually, it's really helping to dip the in-betweens. I'm curious if I set that back to 0 and use the sustain function to pull those down instead. That's nice. Now let's try the hardware. So we're back at Unity. Flat. Now I'm going to turn it up. Now sustain down. Now back to Unity. I'm going to turn up the third channel. And up the sustain a little bit. Down the other way. Back to Unity. Here's the software of the SPL. I'm going to put the second one on so that we're sort of matching. I'll bring the sustain back to Unity. So here's 2SPL software. Here's the hardware. What's interesting is I'll say the hardware is much more consistent in picking up the transients all the way through. It misses a few in the software version, which is interesting. Next is something I wanted to choose that's a little more unconventional. So I wanted to see how these things would react to something like a tiger growl. This is something that maybe you wouldn't normally think to reach for a transient designer on, but it's something that's relatively soft in its envelope to begin with. So I wanted to just see and experiment what the behavior here would be without knowing ahead of time. So I'm going to start with everything flat and give it some attack. Pull the sustain down a bit. Let's add a second one in. Attack all the way up, sustain down a bit. If we added another just for fun. You can see it's doing something. We'll do a fourth just to go crazy. So now it's actually forming a transient where there wasn't one previously, and I think it's using this initial attack here and reading that as the transient. Let's bring the sustain back up on all these. So pretty interesting. I'm going to bypass them all. All back in. Definitely gives it a little bit more of an attack there. And how about Spiff? I'm going to pull the sensitivity down. You'll see it's kind of picking up stuff that it shouldn't over there. It's creating like a bubbly sound at the end. See if some low end and some top end will give us a bit of a snap. So it is a little bit. It's not a very pleasant sound though. And then the Transient Designer from Kilohearts, Transient Shaper from Kilohearts. I think this one definitely does the best job of giving it the transient out of the gate without a whole lot of extra fuss. Let's pick the pump up. It's interesting. Now, I don't know how useful this would really be in real life. It's just an interesting experiment. And last but not least, here's the hardware unit. So it's definitely doing something there that the software wasn't. Maybe bring the sustain all the way down, I'm curious. Pretty interesting. All right, so there you have it. It's an interesting comparison. I gotta say, in this particular demo, back and forth, The hardware, there's definitely less of an advantage. There were some things that definitely did better. Like I think the detection in the circuitry of the analog hardware is much better. Like it was able to detect much more consistently the transients. When it came to like the tiger growls, it was able to create transients better. There were some examples where I thought it actually did worse. There were some examples where I thought the SBO transient software did the best. And I gotta say, I'm just a big fan of the stuff that Oak Sound makes. And in fact, that brings me to my very last example. I wanted to show how I would actually use this in a mix scenario as opposed to in a design scenario. And this is something that I actually do on my template on all of my Foley tracks. So let me give you that example now. Okay, so for this last example, I've got a set of footsteps that are recorded here. This is just from a library. This is a pretty good example of well-recorded footsteps. So it's got a clear heel toe. It's got some nice grit in there. I believe that they're walking on sort of maybe like a concrete gritty surface or something. And it sounds fine. It's got a little bit of room on it. But the thing that happens a lot with Foley, especially feet, is they can tend to stick out. And the word that you'll hear a lot of mixers and sound designers use sometimes with Foley is that it can sound tappy. And what they mean by that is that there's quite a bit of transient information on it. The thing about Foley and trying to blend it into production is that you have to imagine that on the day on set, when they're recording dialogue, a lot of times you can hear footsteps from production make it into the dialogue tracks. And so a lot of times Foley has to layer under those production footsteps, and sometimes they're there, sometimes the production footsteps drop out. And so you kind of need it to like blend seamlessly. And so what happens is that Foley is most often recorded pretty close up and high fidelity, whereas when you're on set, if you imagine, the boom is recording the voice actor, but not the feet. Like the boom mic is definitely not pointed at the feet of the actor walking, unless somebody really skimped out on the boom operator. So this is a trick that mixers will sometimes use to help the Foley blend in better with the production. So I'm going to open up Spiff here, and the biggest difference you'll notice is that I have it in cut mode instead of boost. So I'm actually going to be taking away from the transients in the recording, and what that's going to do is essentially emulate what it's like to have a mic that's off axis and to help soften those feet so that they feel more like they were recorded off axis from the microphone. So here it is clean again, just so we can hear it. And now here it is with Spiff turned on in cut mode. It's pretty amazing actually. So I'm just going to turn it up as the person is walking. By the time I get to 10, it has really softened those transients in a way that actually feels really believable. Like it doesn't feel like something has been carved out artificially from the signal. It just literally feels as if the microphone has been moved or tilted off axis from the feet, and it sounds great. Like that sort of is the sound that happens when you're recording production sound on set and the mic isn't aimed at whatever the source is. So this is just a trick that I love using. To be honest, I usually set this somewhere around halfway, and then I just leave these on by default on my Foley feet tracks, and I can just adjust as needed. But as a starting point, this stuff really helps. It's definitely helpful to listen to your Foley source before you put this on, because maybe if you have a Foley mixer and a Foley artist who are really great and they're doing sort of intelligent blending between room mics or off-axis mics and then close mic stuff, then maybe they're already naturally building in some of that natural sound. But using this is extremely helpful as a quick solve when you do have stuff that's really close mic'd that you need to blend. So there you have it. I hope you learned something. Transient designers can be extremely useful tools for us in the design world. They can also be used in mixing, as you've seen, and there's a variety of them out there for you to explore and choose between. There's also a lot more from other companies that I didn't mention, but the concept works the same on all of them with some unique twists depending on which plugin it is that you're opening. So I hope this helps. I hope you enjoyed. I hope you learned something. If you liked it, do me a huge favor. Please hit the like button down below, leave a comment, make sure you subscribe to the channel. I'll have more content coming your way, and I'll see you on the next one.